Alright everyone, today we are going to be discussing acidity in terms of third degree, second degree, and first degree, along with carbocation rearrangement. So let's look at the top section here. Let's not use that. So above the green line, which amine is going to be more acidic? Now, we have three options. So we have a primary amine, secondary amine, and tertiary amine. In this case, our most acidic amine is going to be primary because it has those two hydrogens. And that is what's going to make it more acidic, whereas the tertiary has no hydrogens. Now, when we look at our alkane, which is primary, our alkyne, which is secondary, and our alkyne, which is tertiary, well, which one do you think is going to be more acidic? The answer is going to be our tertiary. And that is because it has more S character. Now let's write that in. Perfect. So it has more S character, which is about 50%. So SP in this case is going to be 50% S character. Whereas our primary is going to be SP3. So that's not as much S character as our SP with our alkyne. Now, I know what you may be wondering, or maybe you're not wondering about this at all. But what about a benzene ring? What if I drew a benzene ring? Where does that fall in this case if we have a hydrogen attached to it? Well, our alkene is still going to be more acidic than our benzene ring. So let's add that in too. Ooh, I forgot the K. Forgive me everyone, I'm a little bit sick. Anyways, so let's move on to our next generally confusing topic, and hopefully you're not confused over this. That's the goal. Where is our carbocation going to arrange? Now let me zoom in just a little bit more so you guys can hopefully see better. Now we have a few different options. So all three here, those are all methyl groups. And then over here, in case you can't visualize it, we have a hydrogen. Let's draw that a little bit better. So we have a second degree carbocation, and now it can maybe it can do a methyl shift to be tertiary. So we have 4 degree over here, or it can do a hydride shift to also be tertiary. Now, this molecule over here, this is classified as tertiary because it has the 3 carbons, in case that was a little bit confusing, whereas over here it's quaternary because it has 4 carbons. So we're counting the carbons, everyone. Now, let's see. Are we going to have a methyl shift? Or a methyl shift, or a hydride shift? Well, in this case, we're actually going to have a hydride shift to get that tertiary carbocation rather than the methyl shift, and that is because it is less energy to move that hydrogen than to move an entire methyl group. I mean, if you think about it, that hydrogen is a lot smaller than if we were to do one of the carbons, where we would have a whole bunch of hydrogens. That's a big molecule, right? So that's going to take a lot of energy, and molecules like to do things that are lower in energy but are still stable. So either way, we would get that third degree carbocation from this rearrangement. So I hope this video helped out. Certainly is going to help me out when I study for the MCAT. So good luck everyone on your studies.